Welcome to the Data What Friday. For those who don't know me, so my name is Marc Finger. I'm working as Senior BI Consultant at Scalefree for a couple of years now. And today in the Data What Friday session, so I received one question here. And this question is about the zero key concept in Data Vault. And what I want to make sure, because I read why I read the question here, is that, and this happens a lot of times, that people mix up the zero key concept and the ghost record concept. So these are the objective they follow, or the objective they want to achieve are the same as performance improvement, right? And the way how they're working is very similar, but these are two different concepts, right? So two different concepts applied on two different places in the data vault. So, all right, but let's read this question here first, and then I start with my explanation here and to hopefully clarify this. In hubs, so the question is, in hubs we add two ghost records, one with zeros here, or unknown zero keys, right? And another with Fs. I think with the Fs, I think here this is related to the, of course, depends now which hash algorithm you use. When you use MD5, for example, you have 32 characters. If you use SHA1, you have 40 characters, right? And the Fs is, if you use MD5, you would have 32 times the letter F, because the letter F is the highest value in the hexadecimal format, right? So you have 0 to 9 and 8 to F. So this is the first thing what I recognize here is that in hubs we add the ghost record. So this is already, let's say, wrong from the terminology perspective, because we add the zero keys in the hub, right? So, but let me explain this after this here. So the main question here is, in the loading of the stage, in which cases should we replace the generated hash key with the error key instead, and how? So this is the question, and one additional hint how they do it right now. Right now, with the business key or combination of business keys is null, we are always replacing by the zero key. My question is, in which cases should we use the ffff key instead? So, okay, let's differentiate first of all between zero key concept and the ghost record concept. So the ghost record concept is used in the satellites, and used or replaced by using a call-less function in the point-in-time tables. So the point-in-time tables are a join index table which point for a given point in time, which we call snapshots, by the way. For any snapshots, we want to see which delta was active at this snapshot date, right? So, and this is the pointer from the point-in-time table into the satellite table. The problem we have here when we create those snapshots is that when we want to create a snapshot where we don't have any delta at this point in time in any satellite, we don't want to insert a null value, because this would enforce us to use left joins, right? And one thing what we want to achieve in data vault on the way out is performance, and one thing we want to achieve are equiconditions or equijoins. So equijoins are inner joins with equiconditions, right? So inner joins are across all databases. On some databases, there's maybe no difference. On some databases, there's just a small difference. But in general, there's a better performance for inner joins over left joins, right joins, full auto joins, and so on. So this means we want to achieve the inner joins, and this is what the PID table is doing, or this is what the ghost record is doing. We create a dummy record in the satellite, and in case we cannot find for a snapshot date a delta in this satellite, we replace the join index pointer to the key. We replace it by a recognizable value, and so in the trainings, for example, we recommend to use something like 32 times the number 0 here, and this is what the person who asked this question, I think, means, right? So in the satellite we insert the zeros. Okay, so this is one thing. So, or this is the ghost record concept, and the other concept, and I think this is where the question here is basically related to, is why are we inserting two dummy records in the hubs? And the dummy records we insert in the hubs are the zero keys. So First of all, to explain the zero key concept a little bit, same approach or same objective here we want to achieve is performance. So what we want what we want to achieve is when we join into the hubs by coming from a link, right? So here now we're talking about the joint relationship between links and hubs. And when we join into the link, from the link into the hub, we want to achieve the same thing, inner joins, only inner joins. And now imagine you have a link with let's say 10 hub relationships, right? So you have 10 hub relations. That means you have 10 columns, at least 10 columns in your link, which point to the hash key into the hub. So now imagine the link the value of a relationship or of one key in your relationship is null. I mean, this can happen, right? And this is in a lot of cases valid, right? So let me try to explain this a bit by using by using Excel here. Let's say you have or a staging table, right? So you have a staging table where, say, you have your business key 1 here, you have your business key 2, you have your business key 3 here, right? So you have 3 different business keys, and all these 3 different business keys would now, or from this staging table, you would load now all the 3 hub entities. So that would mean you have 3 hubs here. Let me explain you, or let me just insert here just 1 hub. And here you have something like the hash key, and you have a load date timestamp, and you have a record source here, right? And of course, the business key, let's say this is the business key 1. So this is how the standard hub looks like. And what you have usually in the hub by default, same as what you do in a satellite. As soon as you create a satellite, the first insert you do is the ghost record, right? So this should happen immediately after you create this table, insert the ghost record, and the same thing for the hubs here, right? And also here or Scalefree, we recommend to use also some recognizable values, like, for example, 32 times the 32 times the number 1, for example, and 32 times the letter F in this case. So the difference between these 2 keys is 1 represents null values, which can be null, where the source system allows to be null, and the other one don't, right? So the 1 is an optional null value in the source system. The other value is really an error, right? So it's a logical error, right? Where we say, hey, or where we want to identify this value should not be null in the source system, but it arrived as null, right? But this is not reflected in the hub. This is reflected in the link we will see in a few seconds here. Load date timestamp, you use something, beginning of all days, right? So for example, the 1st of January 1900, record source, we usually use something like system, that we know that this is completely system generated. And business key here, we usually use something like -1 or -2. It doesn't matter if really the 32 times 1 and the 32 times F is, I know this is not the value you would receive when you hash the -1 or -2, but these are also some, let's say, part of the dummy records here, right? But anyway, let's continue with this one. So now you have, for example, let's say this is not business key 1, business key 3. And now you get an entry in your staging table, and you have 3 different business keys. This one here is maybe, can be null, right? This one here in the source system. And this is was also one question, how to do that, right? And this is metadata. This depends on your metadata, or this needs to be read from your metadata. This is not handled by the SQL code itself. It's handled when you generate the SQL code, right? So when you generate the SQL code, you need to know what to replace a null value by when using the call-less function. And there you have to check if the column is nullable or not nullable in the source system. And this is what we're doing, or what I want to represent here. This shouldn't be null, right? So this is a not null in the source system. And let's say this one here as well. Not null. All right. Okay. So now what we already or hashing is part of the hard business rules. And now it depends a bit on where you apply the hard business rules. It really depends on what ETL or ELT tools you're using, what automation tool you're using, and so on, right? So I would do the hard business rules as early as possible. Usually when you have a relational staging area, I would do it there because you have the data already in a relational format, in a SQL, in a relational database management system, right? When we're talking about a landing zone on a file storage, on S3 or on Azure Blob Storage or on Hadoop and so on, there you usually don't apply the hashes already, right? So then you do it one step later when you move the data into the relational database management system. But let's imagine we are able to apply the hard business rules already here. So that means we want, instead of course, we keep the business keys, but we also want to hash them, right? And now let's say we use the MD5 algorithm. And instead of using the MD5 here, instead of, let me do it this way. Give me a second. I think that's better when I do this one, hashkey 1, hashkey 2, and hashkey 3. So I think that's better. So this one here, let's say, arrives as null. This one here arrives, here we have ABC 1 to 3, for example, and this one here arrives as null as well. In the second record, let's say here we have ABT, and here we have, I don't know, something else. Yeah, any key, right? And here we have a key. Oh no, let's say this one here. Now, give me a second. Clean this up here. Null 1 1. Okay. Yeah, let's say this one is null, and this here we get a key. So what happens now when we hash the values? And this is where we already apply now whether we use the 1 0 key here, the 32 times 1, or where we replace the 32 times f. So based on the metadata, the generator would now say, okay, this one, business key number 1, can be null, and it arrived as null. Instead of inserting the null value or calculating the null value here, we are calculating the 32 times 1 in this case. This one here is clear. Here we would say MD5 or ABC 1 to 3, right? Because we have a value here. And this one here shouldn't be null, but it is. Let me remove this example here. 1 is enough here. And here it is not null, and this one is an error, right? So because it arrived as null, and this is what we want to differentiate here by using the 0 keys. We want to differentiate nulls, which can be null in the source, and we want to differentiate them from null values, which shouldn't be null in the source system. And in this case here, we are inserting 32 times f. And these are now two recognizable values you can easily analyze in your raw data vault, in your link tables, right? So in your link tables now you can search for 32 times f or 32 times 1. Of course, you can analyze this, and this is one thing, right? So you can analyze the null behaviors in the source system, and the other thing is performance, right? And because when we load the data now into a link, and in the link we would have the same thing here, right? So we would have all these hash keys here, and of course we would have a link hash key, which is the hash key now from all these 3 business keys. So in fact, it's then just from ABC 1 to 3 in this case here, right? But this is also key. And now what we can do, because we didn't insert null values in the link, we can now inner join directly to these values here, right? So we can join from here to here, we can join from here to here. So the values are already there. And of course, this one here will also exist because we load this from the staging in the hub as well. So we can also join from here to here by using inner joins, always inner joins here in this case, right? And this is what we want to achieve. And the differentiation between the 2 0 keys is just null values which can be null in the source systems and null values which shouldn't be null in the source systems. And this is derived by the metadata. So that means to dive a bit or deeper into the code is when you use the coalesce then by generating the code, the template or the pattern or the macro, whatever you use, right, should be able to generate now the code for, let's move to this one here for the hashkey 1. It's coalesce. Yeah, business key 1. Otherwise, use the 32 times 0, right? In this case. So there, of course, there's an if clause surrounding it, right? So there's an if clause. If null, use this coalesce, or if here in the metadata from the source, or if not null, use the other coalesce function. But in fact, in this case here, we would use coalesce this one, if not replaced by 0, right? So this is for the hash key, right? And in the other if clause, you would have the coalesce. So if it's sorry, no, if it's, no, I'm wrong, wait. So coalesce, so if business key 1 is null, right? And okay, of course, now I'm on the right level. So and this is the null value, right? So you use the 32 times 1, right? Or the other if clause when you see, okay, it's not null, right? And this would happen here. Here is say 32 times f in this case. And that's it. Right. So this is first of all the difference between zero key and ghost record, and the difference between the two zero keys you insert in the hubs is related to the null behaviors or the null settings in the source system. All right, and there's one question. Isn't the setting of hashkey 3 to the error value of the hub a business rule? Shouldn't it be interpreted as business rule and business what? In this case, no, because this is something you get from the source system, right? So there's no interpretation of the data here, right? So there's no interpretation of the data itself, or there's no, we don't change. So in the business world, you usually change the meaning of the data and you really change the values of the data, right? So this is what we don't do. What we do is only affected to the hash keys here, and we keep the business keys in the staging area are as they are, right? And we in the hash keys we just consider these null behaviors here, and we just do it here. So of course, how you deal with that on the way out, right? So how you analyze this, maybe this can be a result in the business one, right? But to bring the source, or to bring the source data, or to make the analysis possible, right? So this is what we already can do by using the hard, the hard business rules, or the hard rules here, by simply differentiating between the not null and null, and therefore using different values for this. All right, cool. Any further questions? I just had a look into the chat, sorry for that. Yeah, you have to remove this test then in this case. Or what you could do is also adding the zeros. This doesn't make any difference then, but what you also could do is adding the zeros to the hub, right? Yes, to have this. If you have a hard primary for key constraint between the satellites and the hub, yes, we could do what we usually do is when you're on MPP databases, you cannot enforce referential integrity by default, right? So, or yeah, they don't allow us because it would take too much time. So what we do is when we check the relationships, or how we call it, the orphan tests between the satellites and the hub, we are removing this, especially the ghost record check, right? So remove this from this orphan testing. Yeah. Okay. Yeah, that's it. Okay. Then thank you for attending and have a nice weekend, and maybe see you next time. Bye-bye.
Thanks for joining today. If you'd like to discuss this further, give us a call on the number below here, and we're happy to discuss this with you. See you next time. Have a nice weekend. Bye-bye.